Okay, well, sorry about that. The other one I tried to rearrange the camera and zoom out and it just wasn't cooperating, so we'll just start a fresh video for the bottom of the page. Okay, so here we are in 4.4, page 3b, and we've got several equations, and the instructions remind us we need to solve it for y first. So let's start with 3y equals negative 9x. And what we want, let's keep our goal in mind, that's always a good idea, is we want it to be y equals mx plus b, because then this is where we can begin our graph on the y-axis, and the m value will tell us how we can move along the line to another point, connect those dots, and we're done with the graph. So y is not by itself yet, it's being multiplied by 3. We need to undo that. We need to divide both sides of the equation, every single term, by 3. When you do that, you get y equals negative 9 over 3 is a negative 3x. Here's one of those situations again where we don't see the b value. We aren't quite there yet. Y equals mx plus b. And as we write it out again, we go, this is what we want, this is what we have. Oh, we're so close. It's just that the 0 hasn't been written in. So our b value is 0. So our b value, which is the y-coordinate of the y-intercept, it's equal to 0. So our y-intercept is 0, 0. 0 because it's the y-intercept. The second 0 because that's what our b value is. And then our slope, in this case, is negative 3, which we can write as negative 3 over 1 to really describe our rise over our run. We're going to go down 3 and to the right 1. Down 3 because it's negative, negative 3 does the down, positive 1, that creates moving to the right. Because the rise is either up or down, and the run is either left or right. Okay, so here is our axis. So that was the 3 things we needed to do. We solved the linear equation for y, so that's our first step. We found the slope and the intercept, so there we go. Our slope is negative 3, our intercept is 0, 0. And then we're going to use that slope and intercept to graph the equation. So here we go in part 3. Here's our y-axis, our x-axis. Here is our y-intercept of 0, 0. Here is our movement. We're going to go down 3 and over 1, and I'm just going to do down 3 to the right 1, I should say, down 3 to the right 1. If I want to be even more confident, I can reverse that. It's also the same as positive 3, negative 1, which would be up 3 and to the left 1. Up because it's positive, down because, or left because it's negative. So up 3 to the left 1. Just to kind of be really sure about my line here, because I'm freehanding it. I don't have a ruler handy. Plus it would hit this little ridge that I have on my board, so it'll fall off there. Okay, so that is our graph for this first one. What if it looks like this? 5x minus 2y equals 10. Remember how I said all 3 of these forms, it's just a rearrangement? This is actually the formal version. It's in ax plus by equals c form. Our goal is still to solve for y. We're going to get that y value all by itself. And then what we'll do is when we strip everything away from what's happening to y on this side of the equation and get it all by itself on one side of the equal sign, we will have created y equals mx plus b. So let's go ahead and do that. It's being multiplied by negative 2 and 5x is being added to it. So we undo that by getting rid of everything that's happening to y in reverse order with opposite operations. It's a positive 5x, so we're going to subtract 5x from both sides. And here's where our early work in formulas in 2.4, this is where this comes in handy, because now we're rearranging equations for a particular variable that we want. It's helpful to us. So negative 2y is equal to negative 5x plus 10. You can write it as 10 minus 5x too, but I know where I'm headed. I'm headed to y equals mx plus b. I want that x piece in front so that I keep it to where I'm used to it. Okay. Next, I'm going to divide both sides by negative 2, which means I divide every term by negative 2. And again, there's a reason why I'm dividing every individual term. The negative 2's go away here and I get y equals negative 5 divided by negative 2 is a positive 5 over 2. I'm not changing that to a decimal because I realize that the number in front of x is our slope, and I want slope to be represented in rise over run. You heard me say from the beginning, hopefully, when people ask about fractions, do you want improper or mixed? I said, you know, for our purposes, improper is going to be very helpful when we get to the end of Math 60. Here we are. It's very helpful. 5 halves tells us a lot more that we don't want to know about that line than 2.5, okay, or 2.5. And then 10 over negative 2 becomes a negative 5. So there is our y equals mx plus b form, okay. Our b value is negative 5, which means we have an intercept of 0, negative 5. Our m value, that number in front of the x, is 5 halves, which means we have a rise over run of up 5 and to the right 2, okay? Or you could think of it as negative over a negative. That's the same thing, which would be down 5 and to the left 2. Both of those will get you on the same line. Let's graph it now. Oops, sorry, my hand slipped there. Plus or minus on the x-axis, plus or minus on the y-axis. Here is our intercept. It's at negative 5 on the y-axis here, 0, negative 5. Our movement, I don't think I'll use the down and the left because that'll take me off the grid pretty quickly that I have here. So I'll stick with my 5 over 2, my positive and positive. The top positive takes me up, 1, 2, 3, 4, 5, and then the bottom positive 2 takes me to the right 2, so up 5 to the right 2. I think I'll go one more, 1, 2, 3, 4, 5, and to the right 2, just to be super confident with my line. Okay, and that's what your graph should look like. Your turn to try. I've got 2 different ones here. Pick one or the other. The difference is this one is one step away from being solved for y. This one requires a couple different steps to be able to solve that. It's a 2-step equation to get it to where it's y equals mx plus b. Okay, hit pause. When you come back, we'll show you the graph for that. The linear equation, the graph, and the slope and the y-intercept. Okay, on number 14, when you rearrange this, you should get y is equal to 9x plus 5. That will give you a y-intercept of 0, 5. It will give you a slope of 9, or 9 over 1. And when you graph it, when I graph the 0, 5, I discovered that my up 9 to the right 1 takes me way off the grid. So I'm going to utilize what I know, that a negative over negative, it all is the same as that positive. So I can go down 9 and to the left 1. So I'm going to go down 9, 5, 6, 7, 8, 9. So I'm going to go all the way down 9 and then to the left 1. And again, another movement would take me off the grid. So I think I'm going to be just fine with these 2 points. Okay, so it should look something like that. If you haven't tried this one, pause again, or if you want to try another one now that you've seen the first one done, hit pause, come back for the graph, the equation, and the slope and the intercept. Okay, when you solve this one, you should end up with y equals negative 2/9 times x plus 0. You may have ended up dropping that 0 out when you moved the 2x over and got 9y equals negative 2x. But remember, when you wanted y equals mx plus b, you got to represent each piece somehow, and so that's where 0 comes in handy. So our intercept becomes 0, 0. Our slope, that number in front of the x, is negative 2 over 9. So we're going to go down 2 to the right 9. We'll start at 0, 0. I'll extend my axes here to make sure it's really clear where we're at. So we go down 2 and to the right 9. I am going to go off the grid here. 2, 4, 6, So it's kind of way over there. Or if I go up 2 and to the left 9, let's see, 7, 8, it's kind of way over there. That gives me enough to be able to create it here. Okay, and there you go. That is instant graphing. We'll see you on page 4, our last page for this section. Good job.